Assalamualaikum and good morning to Dr. Sharon. My name is Nuriatul Afizah binti Tajuddin. Today I would like to present the project of simulation and problem solving report. As we know, a three-phase supply was generated when three coils are placed 120 degrees apart and the whole rotated in a uniform magnetic field. A three-phase AC supply carried three line conductor, which is red, yellow and blue, and the fourth conductor is neutral. The current in the line we call line current, and the potential difference between them we call is voltage line. There are two types of connection. One is star and another one is delta. 2 wattmeter method is the method to measure the system generally used to measure power in three phase. We will see the connection later. The sum of the 2 wattmeter reading equals the total average power absorbed by the load, whether it is Y or delta, balanced or unbalanced. Objective of this project is to investigate and analyze Y-Y connection system transmission and load impedance, current, voltage, and acceptable voltage drop based on British standard or Malaysia authority standard. This project will expose to the regulator and enforcement electric system in Malaysia. ESA by TMB is the reference and guide us to design the three-phase system, and we also need to follow rules referring to Electric Supply Act. By using 2 wattmeter and conventional measuring method, we can evaluate and analyze the active power absorbed by load. Last objective is to familiarize students using PSIM software. Methodology: three-phase power supply is common ways to supply electric in Malaysia. Three-phase system consists red, yellow, and blue phase with equal frequency reach the peak value at different time. The interval between the phase have a constant transfer of power to each cycle and enable them to produce a rotating magnetic field on the electric motor. It is most commonly used in worldwide electric distribution grid system. High tension system is not required neutral connection, but it different with low voltage system are required neutral connection. Most residential use single phase system and three phase system. In this project, Y connection connected to generator side and load side, and the balance load is connected to the circuit. The theoretical and calculation for a balanced system based on formula below. IR equal to IY equal to IB, VR equal to VY equal to VB, VRY equal to VYB equal to VBR, ZR equal to ZY equal to ZB. So first is preparing the circuit YY connection. To prepare the circuit, we use the individual metric number to set as a resistance and rate of transmission loss and load to the circuit. From my metric, the value for the resistance and reactance is 79 plus 33J for transmission loss, 81 plus 9J for the load. And we use voltage of generator is 132 kV with frequency 50 Hz. This is the circuit of YY connection. Now we go to PSIM software learning. We use PSIM 64-bit version 903464 software to design this project. Set up three-phase YY connector as in figure 1. This is figure 1, and simulate the circuit to achieve our objective to get test result and value. And the third one is we use 2 wattmeter method. This method is to measure the power delivered by three-phase 4-wire system. By connect this meter in each of phase, we can get the total power by the sum of the 2 wattmeter reading. This is the connection of 2 wattmeter method to get the total power measurement. Below is the flow chart and the procedure for this project. So we go to the start, find the value of calculation method, we download the PSIM, we construct the three-phase circuit YY connection, we run the simulation, and then we get the result and the waveform. The next one is use 2 wattmeter method. We run the simulation, and then we also get the result and the waveform and the process. Now we go to the calculation of theoretical using formula from the given of voltage of generator 132 kV and also the transmission load and transmission loss and load. Based on our metric number, we can get the phase voltage, the line current, the load, the phase load voltage, power factor, active power from the conventional measuring method, and power from the 2 wattmeter method. And the last one is voltage drop percentage. The result and discussion, figure 5 is three-phase YY connection circuit construct by using PSIM software. The result simulation circuit in figure 5 for VAB, VBC and VCS as shown in figure 5A here. Here is the sine waveform and the simulation YY connection circuit. Now figure 6, three-phase YY connection circuit construct using PSIM and using 2 wattmeter to measure total power by finding voltage and current between line. This is the circuit, the construct circuit of 2 wattmeter method to measuring the power. From the construct circuit in figure 6, we find the waveform from IAA and VB1 for P1, and the figure 8, we find the waveform ICC and VBC for P2. From the PSIM simulation, we can get the data is for line voltage, phase voltage, load line voltage, phase voltage, load line current, power factor, active power using 2 wattmeter method. Observation. From the result, the power factor is fulfill Malaysia standard requirement. According to ESA, minimum power factor for voltage 132 kV and below is 0.85 and voltage 132 kV and above is 0.9. Voltage drop for this circuit is 50.7%. Discussion from the project. We can measure the line voltage and current in three-phase circuit. We can determine the power factor and voltage drop percent using formula. We also can determine the same waveform for each phase in the different time. We can compare the value from simulation and calculation, and the last one is show that the resistance and reactance is important to make sure the circuit follow the requirement. And last one is conclusion. Three-wire system mean is there are 3 line current, red, yellow, blue. 2 methods to determine value, voltage, current, and power in the circuit. 2 wattmeter is to measure the current in the 2 of 3 lines. Any point in the last one, any point in the three-phase system can be used as a reference angle when using 2 wattmeter method. That's all from me. Thank you.